Right, let's continue. So you may have heard of these chat GPT, chatbots, AI answering questions, doing a whole lot of things in these recent years, and you may or may not have tested either of these chatbots. So today we are coming to take a look inside what's behind these chat GPT model, these generative AI, all this AI that's coming up, what's behind it? What's the algorithm? What's the model behind it? Now, the first thing you need to know today, right now, about all the chat GPT, chatbot, everything is that they are called large language model. Large language model. What is actually a large language model? It's a type of artificial intelligence algorithm. What's an algorithm? Every day I keep on repeating it because this is a vital thing you need to know. Now, an algorithm is the step by step way of solving a problem. Now, a large language model is a type of artificial intelligence algorithm that uses deep learning techniques. What is deep learning? Now, deep learning is a model or a way where you actually train a model in a way whereby the model can be able to make decisions, analyze decisions, and give out results. Now that uses deep learning techniques. So you can train data based on the data you've trained. The AI can be able to make predictions on that data. So it's an algorithm that uses deep learning techniques that massively large data sets to understand, summarize, generate, and predict new content. Now, you may have come across the term generative AI. Generative AI. What at all is a generative AI? Apart from these large language models, the LLM, we have a generative AI. Now, it's also closely connected with the LLMs, which are in fact a type of generative AI that has been specifically specifically designed or architected to help generate text-based content. So it has actually been trained in such a way it can generate text-based content. Now, some AI tool can actually generate pictures. So for today, we will test a site. Let's see, a site that's able, an AI site that's able to restore all your old pictures. So if you have a picture that's fading out, I mean digital, that's fading out, you can send it there. The platform can actually retrieve it back. Let me see if I can. So we will visit it so that you can actually have a look. So it's called restore of AI. Now I'm showing a tab for you to see here. Now, this website, what it does is it actually restore all your old photos. So you have a photo that has been faded off. So we have an example here. You have a photo that's actually looking like this one. You can bring it here, upload it here, and it will restore the original photo for you. These are all part of generative AI. Right. So you can actually keep the link. If you have an old photo, you can try it. It's the link is I'll also send in your Slack channel. The link is I'm sending it there so that those who would want to use it, you can use to restore your old photos. So you try it. Yes. Okay. So it's in your Slack channel. Now let's continue. Now this restore photo uses generative AI. So generative AI can generate text based, generate or look on something, then generate similar things. So that's how the concept of generative AI comes from. Let's move on. Now, in fact, over the years, we have so many forms of human language, and through which technological communications has evolved. These provide words, semantics. Those in coding class, you will know when you want to program something. There are so many languages you can choose from. You can choose Python, C++, JavaScript, Java, a whole lot. They are all languages. Right. Now, what is the language an AI use? Now, the first AI language model traced their root to the earliest days of AI. It's called the ELIZA language. Is one of the earliest examples of AI language model. In fact, all language models are first trained on a set of data. Then they make use of various techniques to infer relationships, then generate new content based on the trained data. Language models are commonly used in natural language processing application where a user inputs a query in natural language to generate a result. Now, what all this means is for you to build a chatbot like this ChatGPT and so on and so forth, you will need a data set to train a model. So these chatbots you've been using, they've been trained over the years. Now, based on the data they've been trained on, they provide responses to you based on the data they've been trained on. So you asking it good morning, it has been already trained on good morning phrases a long time ago. It knows it has been trained that when someone asks you good morning, respond good morning. How are you? Say I'm fine, or so many ways. They give similar responses in the form of data to this model. So they train it with a data set. Then after training with the data set, the AI model, the deep learning techniques, draw patterns, use this data set which is being trained and generate content based on such data that are being trained. Now note, there is no way a language or an AI model that's being trained on mathematics, you go and ask it this English word and it will give you English word. No. So whatever AI bot you are using, the chat GPT, this, the content or the whatever data is being given to you, you are excited about, they've already been trained on. They know it. If someone asks you this, say this. If you so when you ask it a question that it hasn't been trained on, so let's say it was never trained on when someone asks you, have you eaten? Or but yes. Now, when you ask that question to that AI, it tries to go through the data set, find similar data, and based on it, it generates content on you. So we can get it here, then generate new content based on the trained data. that brings the deep learning here. It can so let's say it's like you've been able to teach a child, a 4 year old child, 1 plus 1 is 2. That's what you as a teacher you taught the child. Now when the child goes to or meet colleagues and the colleagues asks the child, what is 2 plus 1? Though you taught him or her 1 plus 1, he or she is being asked what is 2 plus 1. Now, based on a model you've actually trained him or her on it, the child can be able to actually make decisions on what is being trained on it and generate a response that actually will be correct or accurate or close to perfect. So the child will be like, okay, I was told 1 plus 1, you added both of them together and you get 2. This time around, I'm being asked 2, then I should add 1 plus it. Then definitely to give me 3. Then the child will tell you, oh, 3. It's based on the content or data is being trained on that's generating all the queries you've asked and the responses for you. Please, any questions so far? Right, let's move on. Large models or language models are commonly used in natural language processing application where a user inputs a query in natural language to generate a result. As we all know, this chat GPT or this chatbot and so on and so forth, you actually um, input a text, then it generates for you. So how are you? So let me try and open one chat. Um, one that'll be very close so that we can use that one as a reference. Okay, it's so open. So when it opens, trying to open chat AI chat model so that we can use it as a reference. Still open, so let's move on. And finally open, we will use it. Okay, so some example of these generative AI, we have this BARD and Chat GPT. That's the BARD is Google. So you know, ChatGPT is developed by OpenAI, the company OpenAI, and BARD is developed by Google. I will assume most of you haven't heard of the BARD because it's not fully um, um, uh, let's see, available for consumers. But if you search for it, you know it's there. It's called BARD, the BARD. But Google also has it. Right. Let's move to how do large language model work. So how do these even work? How do they work? Okay. So I'm trying to open an AI chatbot so that you will use that as a reference. Okay, that's come. So I'll just log in. I'm using my folder space chatbot. That's the closest I can use. Yeah. So I have this. So I'll just go to my AI here. So they have an AI assistant here. So today we'll be using the AIs. It says ask me anything. So let's say good evening. Good evening to you too. So this it's a large language model developed by my folder space here. Now they've trained this is the same as the chat GPT and so on and so on. So they've trained this on a data set. Now I've asked it good evening. You can see how it responded. It responded as if it's a human being. Now it's not a human being. What it's doing is it's actually searched through the data set it was being trained, find similar responses to these similar questions, then give you the perfect one it wants to give you. So I'll ask, have you eaten? No, I haven't eaten. So I'll ask, let's say, um, what is maybe Wikipedia? It tells you Wikipedia is a free open content, blah 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 blah, so many things. Now it's been trained on a large volume of data set. So whenever you ask it a question, it goes through the data set it's been trained upon, then fetches you the correct or the corresponding answer or the content based on the data set that's being trained. So we'll be using it throughout our lesson today. Let's move on to our lesson. Now, how do these large language models work? So how is this AI working? Now, at the foundational layer. Now, let's take note. LLMs take a complex approach that involves multiple components, right? At the foundational layer, an LLM, that's the large language model, needs to be trained. The key word here is trained. There is no way, there is no way if this AI is not trained can be able to respond to these my questions. It has been trained on large language model. So you see an AI responding to it's not magic. It has been trained on data that finds to solution or similar solution to similar questions. Maybe it wasn't trained on what is Wikipedia, but it knows what Wikipedia is, and it knows when you ask the when you say what is, you are trying to demand or you are trying to look for what Wikipedia stands for. It uses its deep learning, connects the two together, and gives you what Wikipedia is. Very simple. I want you to understand how this AI all these chatbots are working. It's being trained on large data sets. So when you ask it something, it goes through the data set that's been already trained on, uses its deep learning techniques, and find the correct answer to your question. I might ask it, give me steps to create a YouTube account. Give me steps to create a YouTube account. So I can say, give me steps. Enter. Now it will start saying all the steps one by one by one by one. Now you can see it will write every step you need in creating a YouTube account, and probably add how you can even monetize, you can even ask it, and it will give you everything. So if you follow these steps, you are going to create a YouTube account. Very simple. Now, how is it able to generate this? It's able to generate this because it has been trained on a large data model. This large data set that has been trained, whenever you ask it a question, it goes through the data set it has been trained using its deep learning techniques, make traces, and find the correct results for your question. Please, any question so far with this? Right. Let's move to our slide. Now, sometimes this large data model or large language data set is called as a corpus of data that is typically in petabytes in size. In fact, I want to be more specific here. You need to know this data that are being trained on this AI is not about one megabyte data, 2 megabyte, petabyte. That's more. It's more than terabyte. Like it's petabytes. You can imagine the volume of data. So it's not like um 1 gig data. No, the whole volume, petabyte of data is being trained upon. And it doesn't use our these normal machines. It consumes a lot of memories and resources for you to train on this large volume of data. So if you are talking about this large volume of data, imagine it very large because imagine it the- this if this AI can answer. So let me just copy this petabyte and ask the AI. Now imagine something. If this AI can answer almost every question because it has been trained on a certain data set. Now imagine the size of the data set it was being trained upon. Petabyte, like large data volume. So let me ask it, explain in detail how a petabyte data volume um, would be like. So let's say explain in detail to a 4-year-old, a 4-year old, how a petabyte data volume looks like. Okay, let's do it. Looks like. Let it explain to us in like we are a 4-year-old people how a petabyte data would be like. Now it's explaining. It says a petabyte is a very large amount of data. It's so big that it's hard to imagine what it looks like. In fact, it's explaining to a 4-year-old. Now, to help you understand, let's think about it in a different way. So, let's see how it's explaining it to a 4-year-old. Imagine that you have a big box full of books. Each book has 500 pages in it, and each page has 500 words on it. That means each book has 250,000 words in it. Now imagine that you have 1 million of these books in your box. That means there are 250 billion words in the box. That's the same amount of data as 1 petabyte. If you had a petabyte of data, it would be like having 1 million books with 250 billion words inside them. Very simple. So you can see how it explains it to a 4-year old how a petabyte data looks like. Now, how is it able to explain to and understand that we are 4-year-old? How is he able to understand that, oh, we are 4-year-old and he should be able to explain so that we can understand? It has been trained on large language model. It has been trained on a large language model, drawing using its deep learning techniques to be able to explain it to a 4-year-old. So you can ask it so many ways and it can do it. It does this because it has a deep learning techniques that draw patterns on already trained data sets, presumably a petabyte of data. Please, any questions so far? Right, let's continue. The training can take multiple steps, usually starting with an unsupervised learning approach. In that approach, the model is trained on unstructured data and unlabeled data. The benefit of training on unlabeled data is that there is often vastly more data available. At this stage, the model begins to derive relationship between different words and concepts. Now, I want you to understand this. I want to bring it down so that because this is very technical. Now, what he's saying here is trained on unlabeled data. When we talk about unlabeled data or unstructured data, a data that cannot be described, a data having different data combined together. So, for example, maybe we are given a data of fruit, it contains the data of apple, pineapple, mango, all together. That data is called unstructured data or unlabeled data. But if we are given it data about only mango, is called a structured data. So here is an unstructured data. Now, we use an unlabeled data here. Now, it's able to actually derive relationship between words. So for one of the relationship it will know is, okay, according to this data, using its deep learning technique to say, okay, according to this data, whenever what comes, the next thing will come is will be is. So what is? Please hope you are getting my concept. So it starts to drawing relationships. So it starts from here. It begins. I want to show you some concept. It begins to derive relationships between different words and concept. So when you give it this volume of data, it starts to draw relationship techniques between words and concept. So there is trying to understand, okay, most times when the word what comes, it follows with is. So what is? and it will learn further to understand that whenever what is question comes, it means the person is actually asking for explanation to something. Please, any question so far? Right. Let's move on. LLM, large language model, undertakes deep learning as it goes through the transformer neural network process. Now, the transformer architecture enables the large language model to understand and recognize the relationship and connections between words and concepts using a self-attention mechanism. That mechanism is able to assign a score, commonly referred to as weight, to a given item called a token in order to determine the relationship. I want to show you something here. What we are coming to do right now, it's very technical. Kindly pay attention here. Now, let's go to our AI. When we ask it, so let's ask it any question. When was Google founded? Google was founded on September 4, 1998. Okay, it has provided us with our answer. Let's read something here. Now, when it's trying to find concept between words using a technique called self-attention, the mechanism is able to assign a score, commonly referred to as a weight, to a given item called a token. Whatever responses you get, whatever responses, so let me come back. Whatever responses we've gotten, so this is our latest response. Google was founded on September. Whatever responses we've gotten, it has actually drawn patterns using a self-attention mechanism and giving weight to all these. Now, after that, all this that has been given is termed in AI as token. This is token. Let's see. I wanted to show you some back-end code, but it seems it will be impossible for now. Let's see. I want to share something. Okay, I can't share here. Okay. It says I can't share. I wanted to show you a token. Yes, but this is termed as a token. So when it actually uses a self-attention mechanism and actually join these concepts together, it's called a weight. Now, after the weight is formed, whatever output that gives you, so it gave us Google was founded on September 4, 1998. This is termed in AI as a token. So when you use OpenAI, like when you use their chat system, Chat GPT, they have subscription. So they have limited number you can ask. I think it's 25. So ask this one, I can ask so many questions. For them, right in Chat GPT, I think it's 25 questions. I like per hour. So every hour is just 20. So when you exceed, you can't ask it any question again. Now, they refer it as tokens. For if you subscribe or pay subscription to a premium one, they actually calculate it in tokens form. So they will make it okay. So this person has subscribed, let's say $50. $50 they are saying $50 is for 1 year. Now they've given you you'll be able to make 1 million tokens. So meaning your questions or everything. So these are referred to as tokens. So that's why in language model they can be able to actually monetize it. So this if these people wants to, I think they will eventually monetize this thing because it's open. If they decide to monetize this, they will limit the number of questions you are asking this model. So maybe they will indicate here saying this is a free version and maybe you can ask 30 questions per hour. If you want more questions, you can subscribe, let's say $5 a year so that you can ask whatever questions you want to ask in any time. They calculate it using tokens. Place any question here. Today's class is very technical. If you don't understand anything, you let me know. Okay. Once an LLM, large language model, has been trained, once it has been trained, a base exists on which the AI can be used for practical purposes. Once you've trained it, once it has been trained, now it has a fully base, so a fully database or a fully grounds to stand. Yes. So a fully ground to stand. Now from it of which practical purposes can start taking on. Now by querying the LLM with a prompt, the AI model inference can generate a response which could be an answer to a question, newly generated text, summarized text, or a sentiment analysis, such as what we are doing right now. So after they've trained their model here, we can ask it a question. So uh, what happened? I don't know if it can be able to answer the question. What happened in history on the day September 11, 2001? So after it's being trained, it has a base there, then it can answer a question. So it has been able to answer the question. It answers the question by providing an answer to a question in the form of sentence or a summarized statement. So it says on September 11, 2001, four coordinated terrorist attacks were carried out by the Islamic terrorist group, the Al Qaeda, against the US. Two of the attacks were, so this is the World Trade Center attack that happened in September 2001. You'll be able, so based on the data that has been trained, I think they've trained a very large data. So we can answer a whole lot of questions. Right, let's move on. Now, our final topic, then we'll end it here. What are large language models used for? What are they used for? Now you understand how they work. You understand how they are able to answer your numerous questions. It's not by magic or anyone sitting anywhere responded. It's the data they've been trained on, and based on that data, they draw patterns to give you similar response to your questions. Now you know how it works by connecting or finding relationship between words and connecting them using a mechanism called self-attention, then generating the tokens. Now you know all this, you understand how AI chatbot work, how this chat GPT and so on and so forth work. Now, what are they even used for? What are they used for? I believe you can know what they are used for. One, text generation, the ability to generate text on any topic that the LLM has been trained on is a primary use case. Now, this is a key word. This is a key word, a key phrase. Take note. Text generation. It says the ability to generate text on any topic that the LLM has been trained on is a primary use case. Now, if your LLM wasn't trained on, let's say, algebra or statistics, there is no way you ask it such question it will be able to provide an answer. Yes. So the data which has been trained on is a primary use case. It's a base for it to stamp on it to generate the answer you ask, or the answer to the question you ask your LLM. So all these AI chatbots, all these things, they are called large language model. The next one for translation. LLMs train on multiple language. The ability to translate from one language to another is a common feature. Okay, translation. Let's see if um this one can translate for us. So Jenny paper Pavel Santua. So let's see, translate this to English. Jenny paper Pavel Santua. So there's a French sentence. Jenny paper Pavel Santua. Let's see if it can translate. Okay, very simple. I can't live without you. It has been able to translate it. Jennifer Pavlova Santoa, I can't live without you. All right, now let's move to our. Okay, so for translation here, the next one is content summary. Summarizing blocks or multiple pages of text is a useful function of LLM. Yes, it can be able to summarize a whole lot of pages. So if you have a whole lot of pages, you can paste it there, it will summarize it for you. Very simple. Rewriting content. Yes, it can rewrite a whole lot of things. Your text, it has the ability to rewrite your work or anything for you. Classification and categorization. An LLM is able to classify and categorize content too. We have sentiment analysis. Most LLMs can be used for sentiment analysis to help users to better understand the intent of a piece of content or a particular response. So when you talk about sentiment analysis, maybe you've gotten a statement you don't understand, yes, or you have a topic you don't understand. When you ask the AI, this large language model, it will be able to elaborate it for you to better understand. We have conversational AI and chatbots. Yes, yeah, these LLMs can enable a conversation with a user in a way that is typically more natural than older generations of AI. So you can actually chat with an AI like a human being. That's so I say, hey, I need a friend. So very simple. Say that's great. We would love to be your friend. What kind of things do you like to do? So it can chat with you in a friendly way, so on and so forth. Now today we've been able to understand all these chat GPT, this AI chatbot, how they work, what goes into it, and what's actually made of. The token, the self-attention, the large petabytes data, the drawing of patterns between words before it can be able to give you answers. Please, any question?